Now we are going to simplify this question. See, it's given 8 to the power minus 1 into 5 to the power 3, and denominator we have got 2 to the power minus 4. Firstly, wherever there is a negative exponent, in order to make it positive, we have to first bring it to the other side. That is, 8 to the power minus 1 will become 8 to the power 1. So this becomes positive by bringing it down to the denominator. Similarly, 2 to the power 4, see, minus 4 becomes plus 4, but it moves from the denominator to the numerator. Then we have got 5 to the power 3 as the question. Now 8 can be written as 2 into 2 into 2, which means 2 to the power 3. So we will substitute 8 this way and write 2 to the power 3. To the power 1 has no value, so there's no need for writing the 8 there. 8 to the power 1, we will write simply 2 to the power 3. Now we have got 2 to the power 4 into 5 to the power 3. Now you can see 2 to the power 3 means 2 multiplied 3 times. 2 into 2 into 2. And 2 to the power 4 means 2 multiplied 4 times. So cancel it out. Here the power will get cancelled. Only 1 2 remains. So my answer would be 2 into, we can write 2 to the power 1. Same thing. And 5 to the power 3. So you can write 2 to the power 1 into 5 to the power 3, or only 2 into 5 to the power 3. Let's move to some other complicated simplifications. See, we've got a big simplification. We'll break it into simple parts and start solving it. See the first part given. This looks similar to this law of indices, that is a to the power m whole to the power n. This is written as a powers are multiplied. So this law we are going to apply over here. So what we are going to do is minus 2 3 into 2, that is 6. So we are going to write minus 2 to the power 6 plus we've got my 5 to the power minus 3. In order to make it positive, write the reciprocal of 5, that is 1 to the 1 by 5 to the power 3. Then we have got division. Again we have got a negative power, so in order to make it positive, we are going to write the reciprocal 1 by 5 to the power 5. Then minus. Now see, anything to the power 0 is 1. This is also a law. If you remember, this was a law you can see in my previous video. That is, a to the power 0 is 1. Anything to the power 0 is 1. So this will be 1. No significance of the minus sign over here because anything to the power is 0. So 1. After this, we'll move to the next step. See over here, we'll apply the Bodmer's rule, which says that division is to be done first, then addition, then subtraction. So we'll go that way. First, minus 2 to the power 6 remains same. Then 1 by 5 to the power 3. Division will be changed into multiplication, and reciprocal of 1 by 5 to the power 5 becomes 5 to the power 5 by 1. Minus 1 will cancel out. You can see 5 to the power 3 gets cancelled, and here 5 would get cancelled by 3. So 2 remains. 5 minus 3, 2 remains. Now minus 2 to the power 6 plus we've got 5 square minus 1. We'll solve it. See, 2 to the power 6. There is a negative sign, and the power is an even number. So in case the power is an even number, so minus sign will not be there. It will become positive, and 2 will be multiplied 6 times. So 2 into 2 into 2, which is 2 2s are 4, 4 2s are 8, and again the same thing, 2 into 2 into 2, that is 6 2s. It will be 8 into 8, 64. So we're going to write it here. The value of minus 2 to the power 6, that is 64, plus 5 into 5 is 25, minus 1. Now you can see 64, 25 and 1. So we're going to add it. We're going to get 5 plus 4, 9, and 6 plus 2, 8. 89 minus 1, which is 88. 88, now we have to write the answer, simplify it, and write the answer in exponential form. So we can't leave the answer this way. This is not exponential. What we can do is find the factors of this number. See how we are going to find the factors. 88, 2 becomes 44, 2 becomes 22, and again 2 becomes 11. So you can see 2 repeated 3 times. So 2 to the power 3 into 11 into 11. So we can write it this way. We can also write it another way. You can see 88 means 8 into 11, and 8 is 2 to the power 3. So you can think that way and also write whichever suits you well. But I've shown you this technique because this technique you can apply for every number even if it's not that simple, like in this case.